Welcome to class. We are going to finish up hypothesis testing here. So I'm going to walk you through a full problem. I want to draw you a picture first so that we're clear on what we're doing. There's a claim that's made. I'm just going to use the mean as an example, but it doesn't have to be a claim about the mean. It can be a population proportion, standard deviation, variance. But let's say there's a claim made about the mean. Either that something's greater than or less than or equal to or what have you. It doesn't matter how the claim works. But then the idea is we're going to check that claim by taking our population and we're going to pull a sample and we're going to get our sample statistic. So in this case, our sample mean, and we're going to figure out where that is. So in relation to this claim of the population mean. When you figure out where that is, let's say it's right here. Okay, here's our X bar. The area from that test statistic all the way up into the tail is your p-value. It's the probability. So p is the probability that if you pulled another sample, you would get a similar result or further up in the tail. So it's always going to be like at this marker or bigger, or if you're down at the bottom tail, this marker or smaller. So it's the probability that you would pull a similar sample or worse, okay, or more extreme. That's what your p-value is. And that p-value is going to be compared to another area, which is going to be our alpha value. And that value, alpha, is the area in the tail at which we say p is too extreme. So it's our boundary marker. And p can either be bigger than alpha or smaller than alpha. If p is bigger than alpha, which is how I've drawn it here, that means that your test statistic is reasonable and we are going to fail to reject H naught. If your p-value is smaller than alpha, so say we came over here and your p-value was like this tiny piece of the tail, your X bar was way over here, then p would be way extreme and we would reject H naught. So the tail is the rejection region. The main body is the fail to reject region. Also in this scenario, as we learned in chapter 5, all areas under the normal curve have z-scores related to them. So we can calculate a z-value associated with this white p area there. We call this the standardized test statistic. Okay. And then we also can find a z-value in relation to this alpha area. That area also has a z-value associated with it. We usually call this the critical value. So there's two ways to decide if you reject H naught or fail to reject H naught. One is comparing P to alpha, but the other is comparing Z to Z critical. And I'm going to show you that in the context of an example today. But what I want you to understand, this is really nothing new. This is what we did in chapter 5. We looked at areas under the curve and then also the values associated with those. And so we're really doing the same thing. It's just like, do you want to compare the areas or do you want to compare the Z values? Okay. But you're doing the same thing. You're trying to figure out, is my test statistic too far up in the tail or is it in a reasonable area? Okay, so that's the idea. Again, conceptually, that's kind of to renew like what those definitions are. What is P? What is Z? What is Z critical? And now let's jump into a problem. So here's one. We're going to talk about cheddar cheese consumption today. I don't know who thinks of these topics, but it's very exciting. I'm going to write you a list of what you're going to do on these problems. Your online homework is going to walk you through step A, B, C, D. When you do a homework quiz or an exam, I'm going to outline what I want you to do, but you're going to have to actually do these all on your own. It's not going to be multiple choices you go through. So I want to write you a list and show you how this is going to how this is going to roll. The first thing that you want to do is write your claim and its complement. Okay, so maybe I'll put our list over to the side and we'll do these as we go. All right, so that's gonna be for my first step. So what I'm doing in this problem is I do a lot of scanning. I mean, you should, read the whole problem, but what I'm looking for, I'm scanning for the word claim. So this right here says a consumer group claims. That's my keyword here, and that helps me identify the part of the problem that's going to give me this. So what do they claim? That the mean, all right, that tells me that I'm going to be using mu as my notation instead of p or sigma, okay, because we're measuring the mean. And the mean annual consumption of cheddar cheese by United States is at most 10.3 pounds. So that means less than or equal to, remember that chart I gave you last time, pull that out if you need help with the language. At most means less than or equal to 10.3 pounds. This is my claim, and you want to label which one's your claim and which one's not, because remember, we don't do this test based on the claim. We do the test based on which one's H naught, which makes sometimes it feels like your conclusion is not intuitive because sometimes we're not rejecting the claim or accepting the claim. We're rejecting or failing to reject H naught. And so that makes the conclusion a little bit sometimes fuzzy for people. Okay, so you want to be able to go back and say, okay, which one was my claim? Then I'm going to write the complement. Mu is, I flip that over and take off the equal sign, 10.3. All right, my second step is label which one is H naught and HA. So H naught is the one that always goes with the equal sign. So that's going to be this one. HA is going to be this one. Okay. Third step, draw a picture. And in that picture, you're going to pick a tail. So we did this last class period. So I'm going to take my normal distribution here. Okay. And HA is the one that dictates the tail. Because that sign is pointing to the right, this is a right tail test. And that will be important to look up in your conclusion. So we're marking that for ourselves. The fourth step is use your calculator to find either the p-value. Okay, now, so remember the p-values are area under the curve. It's the probability that this sample happens again. And we're going to compare that to our alpha, or you're going to find the z-value associated with that p-value. This is called the standardized test statistic. So if the green part of my picture is my p-value, then the p-value is the area here. That didn't work really well. Let me do this way. The p-value is the green area. My z-value, my standardized test statistic, is the z-score associated with that area. So that's my inverse norm value there. Okay. And you can do either one. Okay. Just for frame of reference, I won't ask you this on exam, but in your homework, this is called the p-value method. And if you choose this is called the rejection region method. Okay. And I don't care what you do. You can do either one. I'll show you how both work and you can choose what you like. Okay. Your online homework will ask you for both, varying depending on the problem. Okay. So you're going to calculate that and you're going to label your picture. Okay. That's your fourth step. So let's talk about how we do these problems on the calculator. Your command that you're looking for, we're going to do a z-test. Now, how do I know that it's a z-test? A z-test is whenever I have a population standard deviation is given. So this is population standard deviation given. So these problems are going to be a little like chapter 6 in that each section, we're going to do the same thing, but sigma is going to be given. Now it's not given. Now it's binomial. We're going to go through that progression again. And that's how you decide which test you use. Okay. So in this case, if sigma is given, it's a z-test, just like in chapter 6, when sigma was given, it's a z-interval. Same. Okay. So you're going to go to your calculator. Let's go to class calc first this time. Make sure you're in graphing mode up here. And you're going to hit statistics. And we're going over to tests here. And this is your first option is z-test right here. Okay. Again, you have an option of stats or data. We'll do a data in a little bit. Okay. First, we're going to do stats and it tells you what it wants you to enter. Mu, sigma, x bar, and n. Now, mu is the population claim. Okay, that's always the claim's always about the population. So that's going to be the number that we wrote in our inequality. So hold on. I just want to take a picture of this so I can pull the info over with me. So this is going to be our mu value, this 10.3. Okay. Actually, maybe I'll just jump back and forth. So that's 10.3. Okay, now sigma. So I'm looking for population standard deviation. Population standard deviation is 2.1 pounds. The next thing I want is X bar. So that's what happened in the sample. Okay, so let's read through this. Consumer group claims that the mean, this is population mean, that's the claim. Okay, a random sample, here we go. Here's the sample information of 100 people. So that's going to be my n value is 100. Okay, it has a mean annual cheddar cheese consumption of 9.9 pounds. That's my X bar. So you've got a population claim and then a sample situation. So we've got a X bar of 9.9 pounds and our sample size was 100. Okay. Now, what you'll see kick out here is p-values. So these are your area values. And the way that class calc does this is going to be the direction that this is the tail of your test. So this is your HA value. So let's go back and look at what is happening. The HA value has an arrow pointed to the right. It's a right tail test. So when I go to class calc, I'm looking for the arrow that's pointing to the right. Okay, right tail test, 0.97. This would be your left tail test, and this would be your two tail test. So see how those match up with how we were doing our tail choices yesterday. So since this is a right tail test, wait, is it? Oh, hold on, let me confirm. Yeah. Cheddar cheese is at most less than or equal. Yeah, so it's a right tail test. So I'm going to use this value right here. My value is 0.97. Now here is my Z value. That's the Z value that's associated with that area. So you don't have to do your inverse norm. You can just pick either one you want right there. Okay. So 0.97 and negative 1.9. Okay, so let me draw this a little more accurate. Now I know what my numbers are. So here's 0.97. Negative 1.9. Now, why did I draw it that way? Okay, let's talk. First of all, it is a right tail test. So that means that I'm coming from the right. But my p-value is 0.97. That's almost the whole thing. So as I'm shading, I'm starting at the right because it's a right tail test. And I'm shading until I get to 0.97, which is way past half, right? Okay, now let's talk about the z-score. Does that make sense? Well, the middle, this is a standard normal curve. The middle's 0, right? So if I go way past the middle to all the way to 0.97, it does make sense that I have a negative z-score here, right? Because negatives are on the left, okay? So what does that mean? That means that the probability is really high that this situation occurs again, okay? So your p-value is big. Now, you can choose to compare your so that's step 4. Step 5 is compare your p-value with alpha or your z-value with what we're going to call z critical. Now, what z critical is the z-score associated with alpha. All right, so let's just label this on the picture so you can see what's happening. It says that alpha is 0.05. Now, this is a right-hand tail test, so my alpha is going to be coming again from the right-hand tail, but my alpha is only 0.05, so it's a small piece of that right-hand tail. So obviously, P is bigger than alpha, okay? But what is the z-score associated with this alpha? This is going to be my z critical. Now, this you do have to calculate by doing your inverse norm operation. So let's do this once. The reason, so I tend to default to comparing P with alpha because it's easier, it's faster. I don't have to do this calculation that I'm going to do here. Okay, so it's up to you, but I'm going to show you how to do this. So if we want to look at z critical, what I'm going to do is I'm going to do an inverse norm on this 0.05. Now, remember that inverse norm measures from the left. So I'm not going to enter 0.05 as my area. I'm going to enter 0.95. Okay, so let's go over there and do that. You scroll down here. I'm going to go stat distribution plot. I'm going to do a normal distribution. Okay, TIs, I have not forgotten about you, so hang with me. 0, 1, because I'm standard normal, okay? And then I'm going to go back to stat distribution plot and do this dot inverse CDF. What area do I want to measure? 0.95. And here's my z-score, 0.1 or 1.64. So that's what this z is critical, 1.64. So when we compare with this, there's two, depending on what you're doing, I'm trying to teach you 2 things at once. I promise this will get easier. Okay, stick with me. If I'm looking at my P and my alpha, then I'm looking at which one's bigger. So if P is bigger than alpha, then we are going to fail to reject H naught. Remember, we always assume H naught is true. If P is less than alpha, we are going to reject H naught. That's the plan. So P is small, that means it's way in the tail, it's unusual, we reject. P is big, we fail to reject, okay? Now, if you choose to compare Z and Z critical, this is just a number line situation, okay? So if I'm gonna write it this way. If Z is more in the tail than Z critical, then you're going to reject H naught. Okay, so what I mean by that is if I have this situation and here's my barrier, here's my Z critical, and if I find that my standardized test statistic is way up here, like more in that tail, then I'm going to reject. So again, you're in that rejection region. It's the same concept. You're just comparing numbers instead of areas. Okay. If it's less in the tail, then you're going to fail to reject. All right. So that's your step 5. So because of how my picture is drawn, my p-value is definitely bigger. I am going to, my conclusion is I'm going to fail. Sorry, that color doesn't show up. There we go. Fail to reject H naught. Because I'm looking at this. I'm saying, hey, P is bigger than alpha. So I'm going to fail to reject H naught. And then your last step is write your conclusion. Now, the conclusion can be confusing because we're talking about H naught, and H naught may or may not be the claim. Now, in this case, it is the claim. Okay. So I think you'll see that this is logical, but I think that just to be safe, there is this chart in your book, and you could take a screenshot of this if you want. I pull this up every time. So this is how this works. The first thing is, what is your claim? Did you decide that your claim is H naught or HA? So I go up here and I say, claim was H naught. So that means that I'm in this column right here. Okay. And then what did you decide to do? Well, we decided to fail to reject H naught right here. So this is my decision. There is not enough evidence to reject the claim. Now, let's look at this logically and see if this makes sense. So I made a claim. That was my H naught. I failed to reject. Okay, so that means I can't reject the claim. So my conclusion is there's not enough evidence to reject the claim. That makes sense, right? Okay, that's the idea. Now, does that mean that the claim's true? No, not necessarily. Okay, so this situation is one of those situations where it's kind of vague, right? Remember what we said. If you want to really come with a strong outcome, you want to make your claim be HA. And some of these are and some of these aren't. Okay, but when you have your claim as your H naught, you get a lot of vague results, like not enough evidence to reject. So I can't reject it and I can't accept it either. I don't know. Okay. I'm no better off in this scenario. And so this is the plan. Okay. These are your 6 steps for every problem. And I promise this is a lot of information on the front end, but we're going to be doing this for the rest of the semester. And you're going to be able to do this with your eyes closed very soon. Okay. So keep with it, keep practicing. I want to do one more problem. Okay. I know I don't usually do multiple problems, but I want to do one more with data here, just so you get the rhythm of what we're doing again. Okay, so I'm going to go through my steps. The first thing I'm going to do is write my claim. All right, so I'm looking for the word claim. Oh, here it is. Okay, let me get a different color. Claim. Okay, my claim is that the mean time. Okay, so again, I'm using mu, mean. It takes for smokers to quit smoking permanently that means equals in math land 15 years. So this is going to be equals 15. This is my claim. The complement of that is not equal to 15. All right, that's my first step. Second step, decide which is H naught and HA. H naught always gets the equal sign. HA gets the other one. Third step, draw a picture. Decide what tail this is. All right, this is in a not equal situation, so that makes it a 2-tail test. That means I've got these 2 rejection regions now, okay? Whereas if it's a 1-tail test, I only have that 1 rejection region. Now I have 2. It can happen at either end. All right, and so now we're going to put this information in our calculator. I just realized I did not tell my TI people how to do this. Thank you and sorry. Let's do that first on the TI. Scrolling up here. When you go onto your TI, you are going to go first into stat. I'm going to show you how to do without data first, okay? And then we'll do with data. So I'm going to hit stat. I'm going to go over to tests. And your first option is a z-test. That's what you want to do. That opens up your window here. And it asks you, first of all, are we doing data and stats? Let's do stats first from the previous problem. Okay, let's run through that. The first thing it asks you for is mu naught. That's your claim mean. So that's going to be your 10.3. Okay, so this is going to be 10.3. My next option is going to be sigma. That's my standard deviation. So that's going to be 2.1 pounds. 2.1. My next is going to be my mean, my sample mean. I think that was 9.9. And my sample size was 100. Okay, now look at how you pick your tails. Here it goes, mu, and then colon, not equal to mu naught, left mu naught, and right mu naught. These guys right here are your HA statements, just like class calc, it's an HA. So if I go and I look at what my HA was, it's right here. It's an arrow to the right. So I'm gonna highlight the arrow to the right, that one, and make sure you push enter on it so that it makes it dark. And then you're gonna hit calculate. And what you're going to kick out, there's a couple of things that this kicks out. The first one is mu, oops, it'll say mu is greater than 10.3. This should be your HA statement. It's a nice little check that the TI puts on. If that's not your HA statement, then you picked the wrong option in the previous screen. So I go real quick check. I go, let's see. Yeah, that's what my HA looks like. It's pointed to the right of 10.3. Looks good. Okay. Then it's going to kick out your Z value and your P value, your X bar and your N, which we knew anyways. So this Z and P value are going to be your 0.97 and your negative 1.9. Again, you get to choose what you want to compare. Okay. In my opinion, the P value is way easier to do. So that's how you do the TI for stats. Now let's go back in there and let's do data. So now I want you, so first of all, when you have a data set, you need to enter it as a list. So here's our problem right here. Here's our data set. Okay. You're going to take that and we want to enter it into a list. So let's remember how to do that. Go hit stat. You're going to select edit. That's going to be your screen comes up with your lists. You're going to choose L1. You're going to highlight L1, push clear and the down button to clear out your list, and you're going to enter all your data in list 1. Okay. After you're done with that, you're going to go back into stat, and now you're going to hit select tests. Again, you want Z test. And now when that square pops up, you want to select data at the top. And when you do that, now the options change a little bit. It's still asking you for your mu naught, which is your claim mean. Then it's asking for sigma, which is your population standard deviation. But now it says, where's your list? So it's going to get your X bar and your N from your data list. So you're going to enter L1 here and then pick your HA value and then hit calculate. Okay. Now let's hop over to class calc because that's where I actually have my data entered, and we'll get some answers so you can check your answers. So let's see. My mean value is going to be 15 and my standard deviation is 6.2. I'll try to remember that. Okay, so I have my data entered here. Right here. And remember, you need to call it a letter. So A equals, and you need square brackets. I also double check my numbers, and I also make sure I have the right number of numbers in there and I didn't forget something. Okay. Tap on the next line. We're going to go into stat. We're going into tests. And we're doing Z test. And this is our toggle button between stat and data. So I'm hitting data. And so now what it wants is what's the mean, standard deviation, and what's your list. So I've forgotten already because I can't talk and remember at the same time. So my mean is 15, my standard deviation 6.2. 15, 6.2. Okay. And my list, I called mine A. So I'm going to enter that. And then again, you have to choose between your p-values. So this is my TI people. You're doing this too on your second to last row. And because it's a two-tailed, HA is a not equal to statement. So this is my p-value, 0.879. Let's call it 0.88. Okay. This is my Z value. Okay. Negative 0.15. So 0.88. So P is going to equal 0.88. And then if they ask you for the Z value, you can enter that. But I go straight from my P value to comparing it to alpha. I just think that's the fastest way. So here's my alpha value is 0.05. P is 0.88. And alpha is 0.05. So P is bigger than alpha. And if P is bigger, then we are going to fail to reject H naught. All right. So kind of by chance, this turned out the same way. They obviously won't all turn that way. I just picked this one because it had data. Okay. So then you're going to go to your chart. You're going to say, let's see, my claim was H naught again. So it's the same as before. Okay. And I failed to reject H naught. So there's not enough evidence to reject the claim. Not enough evidence to reject the claim. Okay. Now so that's it. Okay. Let me talk about this picture a little bit. On a two-tailed test, this p-value usually, well, let's go up here. This p-value up here, this yellow region, because it was a right-tailed test, this whole 0.97 gets loaded from the right in because it's a right-tailed test. When it's a two-tailed test, the p-value gets split into half and it gets loaded on the right and the left side. So what's happening here is I'm loading half of it in from here and half of it in from here. So I've got 0.44 on one side and 0.44 on the other side. Okay, so that's because that's half of 88. Also, my alpha value gets split in half. So 0.05, I can never do that simple stuff in my head, but here we go, is 0.025. So that means that my alpha value is 0.025 and 0.025. So that means that it's like this tiny bit in the tail, right? Real small. So that's the alpha is my cutoff mark. It says, hey, if you're in either of these little tails, then you're too far out. But what's happening is my yellow region is way far in. Okay. So the probability that this situation occurs again is 88%, which is pretty big, right? So that's a pretty good, I mean, it's pretty similar sample to your claim. So that's how that works. Now, the z-score, if I was to label this, my z-score for this problem was negative 0.15. So that would be this value here. But because it's a two-tailed test, it's mirrored. So I also have 0.15. Okay. And if I want to figure out my z critical value on this green, right here and right here, I'm going to go inverse norm. I'm going to enter a 0.025 for my z critical value. So let's do that really quickly. Stat, distribution, normal distribution. It's 0 and 1 because it's a standard normal. And then I'm going to go stat, distribution plot, and I'm doing this dot inverse. And I'm going 0.025. So that z-score is negative 1.96. Negative 1.96. And similarly, because it's a two-tail, this is 1.96. So that's kind of how the picture flushes out. Now, practically speaking, if you can just compare your P and your alpha, that gives you your answer. But that's I think it helps to have that picture concept of what you're looking at, especially when we start talking about P or alpha and then your Z scores, being real clear about where those go on the picture is helpful. That's it for today. Good luck. I will talk to you next time.